And if I'd have landed 20 feet behind where I landed, we'd have landed right smack in that crater.
When interviewed, Alan Bean of Apollo 12 initially stated that he had not gone through the belts and did not observe any effects caused by them.
Any ill effects from the Van Allen radiation belts?
No. Now, I'm not sure we went far enough out to encounter the Van Allen radiation belt. Maybe we did.
When it was pointed out that the flight pattern took him through the belts, he changed his story.
The belts are 1,000 miles to 25,000 miles above the Earth.
We went right out through them.
No effects on your cells?
We didn't even know it. I don't think anybody, well, maybe somebody said you went through the radiation belt, but we didn't feel it inside, and we didn't get any, added radiation.
The Space Shuttle went to 365 miles a few years ago because I worked in news. I saw CNN. They said that the radiation belts surrounding Earth are more dangerous than previously believed because the astronauts saw shooting stars with their eyes closed when they got within 600.
Radiation belt. We saw shooting stars, but they're not shooting stars with your eyes closed, although they look like it. If you're out in space beyond the Van Allen belt, and probably within the Van Allen belt, and close your eyes and just pay attention. You don't notice it unless you pay attention. Then all of a sudden you'll see a little flash like a shooting star, except it's like that. There goes one this way. Then one just blossoms. And then not that fast. Maybe you wait 3 minutes or 2 minutes and one goes whoosh. And what's happening is cosmic rays are hitting the back of your eye and exciting those sensors in the back of your eye. So that's what you see. And they got high enough apparently to close it. My guess is in Earth orbit, if you closed your eyes and just paid attention, that you would see them.
The first time they were seen was when they went to 365 miles.
Yes.
That's 650 miles below or away from the radiation.
Yeah, see, it's below. My guess if they just did it tonight. But see, if you're just going to sleep or closing your eyes or it's dark, you don't notice them. But if you'll close your eyes and pay attention, which we had an experiment to do, by the way, then you see them whistling by. Not on our mission, by the way, they hadn't been discovered yet. I saw them one day on the moon. It wasn't dark, and it was kind of dark, and I saw this flash of light. And it looked like it was on the moon, but really it wasn't. It was a flash of light in my eye.
Some scientists argue that the trip through the belts was so brief, that is only a few hours, that the radiation would not have had a negative effect on the astronauts. But the question remains, if these belts are not dangerous, why in the last 30 years has absolutely no country put even a monkey past these belts? The standard excuse is that no one has wanted to spend the money to do so. But to write off every advanced country in the world as too stingy and incompetent in over a third of a century to explore further than 400 miles from Earth really is a bit too much to fathom. It is more likely that we simply do not have the technology to go further at this time. Try to imagine the flight pattern of the Apollo moon missions. NASA says that 3 astronauts took off in a multi-stage rocket, and then 3 days later were in lunar orbit some 60 miles above the moon's surface, going about 4,000 miles per hour, or a little over Mach 6. Then, the spacecraft separated into 2 modules. One astronaut stayed in lunar orbit in the CSM. The other 2 flew down to the surface of the moon in the lunar module.
10 feet. Contact. Engine stop. Okay, Houston, the Challenger has landed.
The first question that immediately comes to mind is how they were able to design a craft on Earth that would perform so well under quite different conditions on the moon, namely in a vacuum and in 1/6 gravity without killing anyone. The Lunar Landing Research Vehicle used to train the astronauts for a landing had a jet engine, which of course would never have worked out in the vacuum of space. NASA's answer to this is that the simulator provided 5/6 or 83% of the propulsion to simulate the amount of thrust that the rocket engine would need to lift the craft while flying down to the surface of the moon. This would be using 83% of Earth's propulsion requirements to adjust for an environment with only 17% of the Earth's gravity? Explanations such as this certainly drive home the point that no matter how convoluted, they will always have a rationalization for everything. After supposedly landing on the moon during Apollo 17, 2 astronauts allegedly spent 3 days there. During this time, they were either in a small capsule, walking on the surface in their air-conditioned spacesuits, or riding around in the $60 million lunar rover.
The lunar surface temperature in the sun should be around 135 degrees today. In the shade, the temperature would again be about minus 100 to minus 150 degrees Fahrenheit. That would be in the shadow of the lunar module.
If the LEM didn't have climate control, and had air in it, would it be hot or cold without the climate control?
If you just took a lunar module, and well, let's take the climate control and it fails. All right, what happens then? You've got air and setting there, it's 70 degrees. If the lunar module is setting in the sun, which it always is, then slowly but surely that temperature inside is going to go up to 250 degrees Fahrenheit. Now, you ain't going to make it because you're going to cook long before that.
What powered the air conditioning?
What powered the air? Batteries. You had a number of big batteries in the lunar module. They powered pumps. They powered the air conditioning. They powered the communication system. And that's the reason we were only able to stay on the moon 33 hours. Later on, we got a little better batteries, more batteries, and we could stay longer.
Now let's examine some problems with the astronauts' time on the moon's surface. In the sunlit areas, the temperature on the surface of the moon is 250 degrees Fahrenheit. If the sunlight struck the astronauts' suits or the surface of the moon, they would heat up very quickly. Considering that they always landed on the daylight side of the moon, the energy from the sun would be radiated directly at them, and additionally, the heat would be collected and radiated by the moon itself. Put simply, the astronauts had no energy source that would have enabled them to reject the sun's intense heat. The moon has no atmosphere. It has a vacuum. Conduction and convection could not practically be used for cooling. The heat would have had to have been radiated away.
I know, Bob. I know.
They carried no energy source potent enough to re-radiate this heat away.
What powered the air conditioning?
What powered the air? Batteries. You had a number of big batteries in the lunar module.
Alan Bean's explanation of using batteries is not convincing. Efforts to explain successful functioning of the spacesuits amount to elaborate double talk.
Fantastic, sports fans.
After allegedly spending 3 days on the surface, the 2 astronauts blasted off, went up 69 miles, somehow docked with the command module traveling at a speed of over 4,000 miles per hour, and then they all flew back to Earth for a round trip of 480,000 miles. Doesn't this seem a bit beyond 1969 technology? How can this be explained as anything other than an accomplishment beyond belief? So what purpose would it serve to contrive such an elaborate hoax? Let's take a brief look at the events leading up to the American space race.